Humanity is at a tipping point. We stand at a crossroads of accelerating change unlike anything ever seen in the history of life. It feels as if the future could tip either way. Between utopia and apocalypse. The risks we face are daunting. But beneath the rampant pessimism for our future is evidence that humanity can not only survive the coming centuries, but thrive deep into the future. But there are three broad paths our future could take. The first is collapse, a great calamity facing the destruction of civilization and possibly even extinction of the human race. Second is plateau, where mankind averts collapse, but hits an upper limit of progress. And third is transcendence, where humanity reaches its full potential, multiplies into the trillions, or morphs during transport into something completely unthinkable. Visualizing these futures will bring the dangers into sharp focus and the opportunity we have as we embark on an unpredictable new journey for planet Earth and for ourselves. Humanity is no stranger to disaster. Our ancestors pulled through asteroid impacts, ice ages, supervolcano eruptions, and deadly plagues, each time bouncing back to new heights. But our biggest threats no longer come from the natural world. Since the dawn of nuclear weapons, the threats of self-destruction have come to dwarf all others. By some estimates, the risk of causing our own extinction is over 300 times higher than extinction by natural causes. The Future of Life Institute identifies four main risks to our survival: nuclear war, climate change, biotechnology, and AI, and the best way to understand how grave these risks are is to consider what the worst that could happen might be. Soot from a full-scale nuclear war could lower global temperatures by up to 10 degrees and erase up to 63% of the population. We have reduced nuclear stockpiles but still have nearly 10,000 warheads still exist. In the trajectory we are on today, we would heat the Earth up by 2.7 degrees by 2100, which would be more than enough to dislocate 1 billion people. But under the worst case, we would set off all the C02 tipping points and as many as 12 degrees of heating over the next centuries. Biotechnology has the potential to solve major crises like food scarcity and disease, but could give small groups of people the power to cause global disaster. In theory, the release of a designer pathogen could have an even higher death toll than a global nuclear war. But the most difficult risk to assess would come from AI. It's actually the first danger that has ever arisen over which we might not be intelligent enough to succeed. It could be a very potent friend, or it might, in essence, outcompete us for the resources in the world and drive humanity into obscurity. This new risk landscape will be the biggest challenge we have yet faced. The more progress we make, the more new, unforeseen threats are bound to materialize. But despite the possible large-scale human tragedy, few of these risks in and of themselves are likely to lead us to our total extinction. In fact, we may be one of the least endangered species on Earth. Our sheer numbers and broad distribution have given us a geographical buffer against extinction. We inhabit every corner of the Earth, from desert to tundra and tiny isolated islands, which could act as natural quarantines in case of global disaster. Even if 99.9% of humans were wiped out in some disaster, 8 million of us would survive, more than at any point in history until recent centuries. And while we breed slowly, we no longer depend on the glacier-like speed of natural selection to evolve. Technology gives us the power to adapt thousands of times faster than any other species in the history of life. Last but not least, our generalist diets allow for wide flexibility in food sources, a trait that was critical to survivors of past mass extinctions. In the end, the threat of collapse hinges on one question: how resilient is civilization? How big of a hit can we take, and keep going? The Black Death of 1347 killed up to half the population of Europe and 1/10 of people globally. But even this did not derail human progress, and it was followed by the scientific revolution just 200 years later. The same proportional hit today would wreak havoc on our interconnected global economy. But as long as our infrastructure and knowledge remained, we could still rebound and maintain an upward momentum. If we suffered a collapse steep enough to extinguish global industry, it would make for a much longer, more precarious recovery. And if somehow we lost the capability for agriculture and were pushed back to hunter-gatherer lifestyles, the Earth could only support 10 million of us, our population as it was 100 centuries ago. At a minimum, there would have to be between 100 and 5,000 survivors to successfully repopulate the Earth. Below that level, the bottleneck would be too tight, and we might never recover. To understand what's at stake, we have to face what extinction would really entail. Our biggest risk doesn't come from one catastrophic event, but from how disasters multiply and combine in unpredictable ways. In 2009, two researchers conducted a thought experiment to see what it would take to drive humanity to complete extinction. Phase 1 sees a rapid crash in human population from global warfare and collapse of global industry and agriculture. Phase 2 witnesses the depletion of whatever resources might have remained in nature over a span of the next 200 years. And in Phase 3, this exercise envisages a downward spiral of ecosystem collapse, punctuated by a supervolcano eruption, leaving the last remaining bands of humanity unable to cling on anymore. Such an outcome would not only be tragic for the loss of life, but for the loss of future potential life. Billions or even trillions of our potential descendants would never materialize. Distant planets would go unexplored. It would mark the end of music, poetry and art in our corner of the galaxy, and perhaps in the universe. The Svalbard Global Seed Bank in Norway now contains over 1 million specimens of seed representing over 4,000 varieties of plant, which one day may prove crucial to re-establishing civilization. But there's an even better place to build a vault like this. Some have proposed lunar arks that would store genetic samples in lava tubes beneath the moon's surface. Here, they would be protected from global disaster, erosion, micrometeorites, and solar radiation. But the best way to ensure our long-term survival is to do something that no other species has ever done: become a multiplanetary species. Once a self-sustaining civilization is established on another planet, our extinction risk drops dramatically. We are going to bring our imperfections with us, and we will face new and unfamiliar hazards the greater distance we are away from Earth, but it will be worth it. A sustainable, interplanetary civilization shall be the foundation for a long and prosperous future. But is this higher future possible, or are we currently at the apex of our abilities? How much farther can we go? It is theoretically possible that civilization will just stick in its present groove and continue indefinitely without either collapsing or evolving. Less obvious obstacles might lead to a sort of restless plateau. But in truth, plateau represents at best a transitional state. In the near term, exponential changes in technology and Earth's climate will force civilization into new directions. And the further we push into the future, the greater the disruptions we will face. In the next few 100,000 years, we are due to face supervolcano eruptions and a new ice age, even if we burn every ounce of fossil fuels and bake the Earth. Without active climate management, the glaciers will have their revenge, as mile-thick sheets of ice steamroll huge swaths of North America and Europe. It's believed that every 27 million years, Earth experiences a cyclical mass extinction, caused by the Sun passing through the asteroid-dense middle region of our galaxy. Photosynthesis and the oceans will slowly evaporate, which will wipe out all life on Earth. Unless dramatically altered, human civilization as we know it cannot withstand these changes. Another option for humanity will be to let nature take its course on Earth and to move on to habitats off the planet. Bishop rings are megastructures in the form of rings that can accommodate more than 1 billion persons. They would provide more than 3 million square kilometers of land, the equivalent of an India or an Argentina. They could be made from lightweight carbon nanotubes, and their rotation would create a gravity strong enough to prevent atmosphere loss. But for those contents to stay on Earth, we are not at the mercy of our planet, and we can write its future. For despite all risks we incur, utopian futures are well within reach, and sooner than one can imagine. To our ancestors, our powers would seem god-like. Everything we accomplished thus far may pale in comparison to what comes next. Since the Industrial Revolution, progress through technological advancement has taken a radical turn toward improvement in the human condition in every critical way. Worldwide, quality of life is at an all-time high. We don't perceive these positive trends as clearly due to our negativity bias, which evolved to make us extra attentive to negative information. But the forward momentum is undeniable. Our course correction to a sustainable civilization now is unstoppable. The costs of solar and wind energy keep falling faster than expert predictions, and are increasingly cheaper than fossil fuels. In tandem, the converging technological advancements in AI and biotech point to a radical enhancement of human well-being. Projects like AlphaFold are uncovering the structures of pathogens and treatments for cancer at a rate much faster than that of humans. There are over 10,000 diseases caused by single-gene mutations, and gene editing tools like CRISPR have the potential to cure all of them. Such upward trends multiply human potential manyfold. We now are the healthiest, wealthiest, freest, best educated, most advanced population of humans that ever existed. If these trends continue into the future, then we might be able also to regenerate limbs, eradicate disease entirely and live even longer.